Now, as we go on to Chapter 2, Section 1, we're dealing with a very important word in algebra and in mathematics, and that is the word function. So we'll be bringing out many things, but I want to give you a little general background, and this is probably something I will have on your classroom whiteboard as an introduction to this. So as we go through this section, we'll be talking about these items, but I'd like to stress this concept here of a relation. Now, one of the reasons they're bringing function in at this point is that just a few sections before, we talked about the ordered pair, the x and the y. And these are connected. When you plot them, you first plot the x and then you plot the y. So these being connected like this as an ordered pair are a relation. This is an example of a relation. Now, we also have, and we see the words right there, domain and range. And what domain refers to are the x elements in, let's say, the ordered pair. All of the x elements are the domain. So you're kind of tying in the vocabulary here. Range. Range are the y elements in an ordered pair. And then we will talk about function. This is a mathematical term. That's what this whole section's about. And notice it's mentioned 3 times here. Function refers to something is a function if the x element in a series of x elements is only used once in a relation. Now, if the x element is used twice, such as if you had 2, 1 and 2, 3, here the x element is used more than once. This is not a function. But if you look at the ordered pair and the x element is only used once, then that, by mathematical definition, is a function. Now, it's a little more complicated than the definition I gave you, but here is this one. A function is a special kind of correspondence between 2 sets. The first set, again, that's the x element, is the domain. The second set is called the range. Those are the y elements. For any member of the domain, there is exactly one member of the range to which it corresponds. This kind of correspondence is called a function. Again, the simple form, the x element is only used once in relation to the y element. Okay? And we'll see this here as we go through various examples. So, we're asked to determine if the correspondence illustrated here is a function. Now, our first elements, these would be our x's. We have an 8, a 0, and a 5, -5. As they correspond to what's in the y elements, are the x elements used more than once? Well, look at it. There's one arrow, one arrow, one arrow, each from a different x element. So this is a function. Now take a look at this one. Here we see this is your X elements here. These are your Y elements. Notice that from this X element, there are two arrows. So this is used twice. This is not a function. The X element's used twice. It's not a function. Okay, now sometimes they get a little more complicated, but here we have a set of rectangles. Think of that as your X elements, your domain. And they correspond to a range of numbers that are the area of that rectangle. Would this be a function? Think about it for a moment. Well, these are individual rectangles, so their areas make up, in a sense, a function relation, because each rectangle has only one area. Now, how about famous singers to records that they make? Set of song titles. Well, does a singer only sing one song, or can that singer sing many songs? Yes, Frank Sinatra, any other famous Beyonce, whoever you can think of, they have many songs. So this would not be a function. Now, it is a relation, of course. You know, every song that a singer sings to the title, that's a relation, but it's not a function. Okay, so a relation, once again, is just a correspondence between the domain and the range, the X and the Y. Now, when we look at a graph and we are asked to see these ordered pairs, what would be the domain? Well, again, it's the first coordinate, it's the X, and the range is the second coordinate, the Y. So find the domain and range of this function. Well, what we're asked to do here, and we can usually do it like so, domain, and we put a brace there. The X value of this one is going to be -5. The X value of this is a 1. Now the X value of this one is a 3. And the X value of this one is a 4. This is our domain. We have just listed the X values. And we usually write it like so. Now, when you are asked to write the range of these, you would then put the letter R, and the range of this one is its Y value, which is a 1. And in a sense, we could pick them right out of the ordered pair sequence. So the second member, so here the Y value is 0. Here the Y value is -5. and here the y value is 3. Okay? These are the relations as their ordered pair. The first element is the domain. The second element is the range. And that's how it would be. There's the domain, and there's the range. Okay, now for something like this, and they'll be asking you this in your practice and in your quiz me, I think a very good thing to do here might be what we call that T-chart. And you might say, well, why the T-chart? Well, because it helps you organize your data here. Now they're saying, what member of the range is paired with a -2? Well, they're asking for the range, so that's a y unit. So they're giving you the x unit. That goes there, -2. What is the domain of this function? And what member of the domain is paired with 6? Again, that would be a y value. You want to find the x there. And then what is the range of f? So domain will be D here. And the range will be R here. And hopefully what I'm showing you is a way to organize your data. Okay, so we have here x is a -2. So where is x a -2? It's a -2 right there. X is -2. So what will y be? When x is a -2, y is going to be about a 3.5. Now, when y is a 6, x is going to be a 2.25 perhaps. Now this is unusual that they give you examples like this instead of having it come right on a line, but that's sort of what you're doing. Now for our domain now, what is our domain? Well, our domain are our x values. And where do the x values start? Can you see they're starting right here at -5? And they go up through 3. So -5, comma 3. And in a sense, you might put that in interval notation that we talked about here. And since -5 is included in the set, and 3 is included in the set, that's what we're going to use. Now the range, again, range is starting at about a -1 here, and it goes up to a 7. But it looks like it's not quite on a -1, so I would use a parenthesis down here. -1, and it's going up to a 7, and that is included in the set, so we're using that notation. And I see the textbook here, the slides are using set builder notation to indicate the domain. So we say that x is such that -5 is less than or equal to x is less than or equal to 3, or as we put it in interval notation, and then the range over here is -1 is less than x because there isn't a solid dot there, doesn't quite meet the axis, but definitely the 7 is included, so is less than or equal to 7. So 7 is included, that's why 7 has a bracket here in our interval notation. Now, when they made this, they were off a little bit, so you'll see that in the next few slides, they show you what we've been doing, but their graph was off a little bit from what I was illustrating. So let's take a look here. So notice here they're saying that for when they're asking locate -2, which is right there, and you see it's about a 3. That's what we had said. And this one, for domain, it starts at a 5, and it goes to the 3. Remember, the domain are the x values. And then for this one, notice the line's a little bit off. We had said something a little bit different, but here they're saying it's supposed to be in the middle. So when they did this graph, the makers of the slide were off a little bit. And whatever they show you. And then the range now starts at a -1. Now notice they're thinking that that -1 hits the line. Here they're using a less than or equal to, so that would be a bracket. But when I looked at it, it didn't quite hit the line, so that's why we said what I did. Okay, but again, whatever is in your lab, I think those diagrams will be much better, and there is a little wiggle room. If there is a challenge on some of this, generally I will give you the credit, okay, on your paper test. All right, now another very useful tool throughout this is what is called the vertical line test. Now, what is the vertical line test? Well, here we are imagining we have a very thin line that we will move over the face of a graph. Now, as we move that line, does the line intersect that graph in more than one place? Well, as you see here, it's intersecting there. Notice they're off a little bit, but that's what they're illustrating. It intersects in 3 places. So if it intersects in more than one place, as you move that vertical line along the face of a graph, we say it does not pass the vertical line test, and therefore it's not a function. So this one is not a function. It does not pass the vertical line test. Now, as you continue with this line over this graph, does it intersect this line in more than one place? And the answer is no. So this does pass the vertical line test. So this is a function. And how about this funny shaped lightning bolt here? It intersects there and intersects there and there and there, there and there. So this does not pass the vertical line test. But all of these indicate relations. The x and y values are related to each other. Okay, now another interesting concept about function notation and equation is that when we do this equation from the last section, y equals mx plus b. And in a sense, we have a series of x and y values. These are related. As we put in an x value into this equation, we come out with a y value here, a corresponding y value. Now, there'll be something here. There'll be a 5, a 7, a 9, let's say. Whatever it is. So x is our input. That's our domain element. And y is our output, our range. So the value of y depends on what we put in as an x. So this is sometimes set up as a little machine here, this formula. We're inputting an x value and we output a y value. We put something in there, it gives us the y. And that's what they're illustrating here. And I think they have a little picture there, yes. So there's your x input. Double it, add 3, you get an output. Okay? This is read as a function notation that I will illustrate here. Now, when we write something in function notation, we use these symbols. The function of x is such that 5x plus 2. Now, one of the things they're going to mention throughout the rest of this is you can always replace the function of x with a y. Think of this as your range. The function of x is this. You're going to input some x value, use this machine here, and that will give you some y value out here. Okay? So if your x value is 3, and I would suggest strongly when you do these, you make a little t-chart. There'll be your x, and here's going to be your f of x. That, remember, is like a y. So we're saying f of x, x is going to be 3. We put a 3 where the 5 is. 5 times 3 is 15, plus 2 is 17. This is the t-chart we worked on in the last chapter. And this is how it relates to function notation. It ties right in, where we could replace this function notation with the letter y. Whatever value they have in the parenthesis here is what you will put in for your x. So they're asking us to do this. How would you do it? What would the strategy be? Now, this can look challenging, but just take it in a form of strategy. So here's our function notation. They're saying that our x value is going to be a negative 2. So here we're going to put a negative 2. Now if we put a negative 2 in there, what does it become? Well, negative 2 squared is 4. 3 times 4 is 12. This is going to be 2 times negative 2 is going to be a negative 4. And this is going to be an 8. All right, now notice they've changed our function notation a little bit. Instead of using the letter F, they can use a G, and later they're going to use an H. And instead of using a letter X, they're going to use a letter T. That's fine. Same principle applies. Where we have the T, we're going to put the 4. So I could put a T there, but I've put an X there. So 4. So 6 times 4 is 24, plus 9 is 33. All right, this one's a little tricky. So here is the function notation, but they're defining x here in terms of m plus 2. That's the value. So here where we have 8, we have the 8, and we say our x is m plus 2. So we put it like so. Now we have to distribute, and we get 8m plus 16 plus 1. So our answer over here, when x is m plus 2, is going to be 8m plus 17. Okay? So again, it looks a little tedious, but remember, again, the T-chart's very useful to give you an idea what they're looking for. They're going to give you some value for x. They may call it by another letter. But then you put that value in the formula they're giving, and that will be your output over here. And there they have it all worked out for you, as we did. So there's 8, there's 33, and there's 8m plus 17. Again, you could pause the tape if you'd like, rewind it, check it out. Now, in this next one, they're asking you to do some using a graphing calculator, which we don't do. But what would be your strategy if you were doing them? Well, there is your function statement. Here is your x value. That's, in a sense, going to be the letter a 3. And then there's a negative 2.3. And you just put your value there, and it's substitution. Okay? Again, we're going to keep ours a little less difficult than some of these decimal numbers and things, as you'll see. And there's how you do it. Okay, now this is an important concept, building you up for later math. It's called the zero of a function. It's sometimes said finding the zeros. So the zero of a function is a function whose input corresponding output is 0. Now, when you make your T-charts here, it's a little bit different strategy, because here you know your outcome is going to be 0. And sometimes there's more than one 0. That's why I've put 2 here. Sometimes there's just 1. Often there's 2, and sometimes there may be even 3 zeros. You have to here find the x values. So in this type of situation where they're asking you to find the zeros of a function, finding the zeros, your y is 0. We don't know the x. We have to do the calculations to determine that. So let's take a look at this one. Now, since the graph is there, it should be pretty easy to do. And again, the strategy is to make a T-chart. And these are going to be, we said, f of a. But remember, in a sense, that's a y. Now, where is y is 0? Well, y is 0 right there. So we're going to have one there and one there. So we do have two zeros. Now, what is x there? Well, right there, x is a -3. And here, x is a +3. So, what are our x coordinates here? Well, it's a -3 and a +3. We have found the zeros of this function. All right, how about this one? Again, I think in a strategy, make a t-chart. And this was f of a, we said, which is our y. Now this one only has one zero right there. So y is 0 there. What's our x value? 4. Okay? So this would be the actual situation where y is 0, x is 4. And I know for some of you this is a little strange, but hopefully little by little you're picking up this mathematical system of illustrating what's here. All right, now on this graph, are there any zeros? No, the parabola never reaches the x-axis where our 0 for y is. So this one has no zeros. By the way, a bonus point for this might be, what is this? Well, these are imaginary numbers. The values of x, I'm sorry, the y value never reaches 0. There you go. Okay. Now, find the zeros of this function. Well, what did we say this was here? This is our y. So what we're looking for here, if we make a little t-chart, this will be x, and this is going to be f of x. Remember, that's y. And we're saying y is 0. So all we do is we put a 0 there. We're going to transpose the 5. That becomes a -5 on this side. Divide both sides by -2. We get x equals 5/2. And there is our solution. Y is a 0 when x is 5/2. Now, could you have put 2.5? Yeah, that's okay, but I think they're looking for 5/2 here. And if you graph it, it's right there. Okay. Well, I think we've done this in our first slide. This is a long video, but again, lots of stuff going on here. And let's take a quick look at this here. And actually, we're not going to do this in our curriculum, but we'll take a look at it here. No. Again, we're not going to have a piecewise function again, this is a fundamental class, so we don't want to get too deep into it. We've done a lot of good stuff here, and hopefully the video is helpful for you.